All are able to hear me or not? Okay, today we'll be discussing the topic how to use pole placement by state feedback to achieve the desired specifications. Already we have learned about state space model. So it is a combination of two equations. What are the two equations? Come on, state space model is a combination of what two equations? This
State
is a
equation and
common
output.
system. Yes, this one is called as what equation and this one is called as what equation? This one is your state equation, this one is your output equation. That is for a general state space model. Yes. So usually we have discussed in the last unit the use of controllers and compensators. For what purpose they are used, controllers and compensators? Controllers are PPA, PID, compensators are lead lag. Okay. So why are you going to use all those controllers and compensators in your system? For what purpose? For what purpose are you designing controller and compensator? You did lab, you studied theory and still no answer.
And
To
still,
get desired output.
Yes, to get desired specifications, you are including a controller or a compensator. That is conventional approach for a single input, single output system. But there is another technique by which you will be able to achieve desired specifications. That is by using a concept that is called as state space feedback. Alright, this is state space feedback. Alright, this one state space feedback you are going to use up, and with the help of it you will be placing the poles to a desired location. With the help of it you will be able to improve the system performance. Okay, so this is all we are going to do in today's class. So the first diagram, if you see, that is a general system for which you already know how to derive the state space model. And you know what are state variables. What are state variables actually? We have did problems also. How to derive state space model we have learned via problem. So what do you mean by state variable? State variables are variables which are with the help of which you will be able to get a knowledge about the system at time t is equal to 0 and at time t greater than or equal to 0. Okay, at any point you will be able to determine the knowledge of the system using those state variables, and the state variables may be physical variables or phase variables or canonical variable, whichever may be. You can choose it to create the state space model. That is conventional approach. But if you see to the second diagram, okay, usual approach is you will be using output as a feedback signal. Okay, you will be using output as a feedback signal in usual approach. But other than these output signal, okay, the state variables themselves, any inner variable can also be taken as the feedback element. Okay, that is why they are called a state space feedback. Okay, not only output can be sensed and it can be used as a feedback variable, you can also use all the measurable state variable, alright, as a feedback element, and that will be called a state space feedback. That is why the name comes state space feedback. It is because of the reason that you are going to take inner state variable as a feedback signal, okay, which are all measurable, that you can take it as the feedback. Suppose if you are having state variables that are not measurable, okay, but observable, so those variables can be used as an estimator. Okay, so this is the concept that is called as state space feedback. So you should know what is state space feedback and output feedback. Output feedback means here the output signal will be taken as a feedback, but if you are going for state space feedback, the state variable feedback will be given. Okay, whatever be the state variables you are choosing, which are measurable, they will be taken as a feedback element. That concept is called as what concept? That concept is called as state space feedback. Alright. Now the original diagram is changed here. So in what all ways it is changed? What are the new things that are added here? Tell me. Comparing these two diagrams, what are the changes that has been made? by observing the diagram. Originally you are having only U, that is the plant input. Now you are adding another input. What is the other input that you have added here in extra at the input side? What input has been added in extra in addition to the plant input?
System input, ma'am.
Sigma.
There is an R factor and sigma. Sigma is a state space feedback. So two inputs are added extra. One is a state space feedback element and the other one is your R, that is a system input. Okay. So now you know how to write sigma. Okay. Sigma is coming from what signal here? This is the point where the signal is what? At this point the signal is X. So X is multiplied with K to equal what value? You can refer to this equation now. What is this equation? Last equation that I am showing. This equation, sigma. Sigma is equal to what?
Kx.
Kx. That is obtained by the state space feedback only. Now if I want to write the formula for U, okay, how can I write the formula for U? U is what I want. So how can I write U? By using R and sigma, how can I write U?
R minus sigma.
U here is equal to R minus sigma. Okay. So how can I write sigma?
K into X.
Kx. Okay, so that you remember, using this equation only you are going to convert this system into the state space feedback system. So you know these two equations are state space model. In this you are having the U factor. So in place of U, what you are going to substitute now? R minus Kx you are going to substitute. And you are going to rewrite the equation. So you can see for yourself these two equations, what has happened here. In place of U, what you are substituting here? R minus Kx you are substituting, and if you are simplifying, the original state equation will be modified like this. In place of A, now you are having what parameter? Original state equation will be having only A here. Now that A is replaced by what parameter now in the new equation?
A minus BK.
A minus Bk. Okay. And other variations are also shown, plus Br you will be having, where R is your system input. Now there won't be any change in the output equation, so everything is okay. Now you are having a new parameter, that is K. Okay. While K is called as your state space feedback gain matrix. Okay, this K matrix is called as state space feedback gain matrix. Okay, by adjusting this K value only, you will be able to pole place. Okay, you want the poles to be placed in the desirable location to improve the system performance. So if you want to do that, you are going to make changes in what matrix? What gain matrix? K. K is called as what? K is called as state space feedback gain matrix. Okay, you have to calculate the state space feedback gain matrix. If you are able to make changes in it, you will be able to vary the location of the pole places in order to obtain the desirable system performance. That you are going to do now with the help of a problem. You will understand it better. Now there is some procedure that you have to follow for calculating all these things. Now have you understood what is the concept that is called a state space feedback? What do you mean by state space feedback? One final time before you go into the problem, I want to summarize the things regarding state space feedback. What is state space feedback actually? Oh, normally in a normal system, you will be taking only output as a feedback element. Output you will be sensing and you will be giving it the feedback. Okay. And you will be adding controller or compensator for a single input output system to give the desired performance. But if you are going for state space feedback, what you are going to do in addition? apart from output, you are going to use the state variables as the feedback element. Okay, whichever may be the inner or outer, whichever may be the state variables that you are choosing, those variables will be taken as a feedback element in addition, forming an extra input that is called a system input R. Okay, that is why this is called as what feedback? This is called as what feedback?
State space
State
feedback.
variable.
State space feedback. While you are doing that, you are adding one gain matrix. That gain matrix is called a state space feedback gain matrix. Okay, only with the help of this matrix, you are able to adjust the pole placement. Okay, you want to place the poles in a desirable way so that the overall system performance may be improved. Okay, that significance of the pole placement you already know. So this concept is called as pole placement technique using state space feedback. Some changes will be there in the original state equation that you have learned how to derive. So these are the changes. Okay, instead of the original state equation, you have to use this equation for the new. Now we will go into the problem, and before going into the problem, you need to know how to derive the K value. For that, first step is you need to determine one matrix. This matrix is called as what matrix? QC represents what matrix? QC is given here. What is QC? There are two matrices actually. Last class we have solved problems. One is observability matrix and the other one is what matrix? What matrix?
Controllability.
Controllability. So this is your controllability matrix. First step that you will do is for the given system you will check out the controllability. Okay. Then next thing is you will be calculating two things. For the original system you will be calculating the gain values. Lambda I minus A you will calculate, you will obtain this characteristic polynomial. Next, they will give you what are the desired closed loop pole locations you want. Okay, using this mu1, mu2, mu3 are the desired closed loop locations. So using that you will frame another characteristic polynomial, you will compare these two. Here the coefficients are alpha 1, alpha 2, alpha n minus 1. Here the coefficients are a1, a2, an minus 1. But remember that you will be using up in forming this matrix. What is this matrix called as? K. K is called as what matrix? State space feedback gain matrix. It is given by what formula? Alpha n minus an, alpha n minus 1 minus an minus 1, alpha 2 minus a2, so on. Okay, so alpha n, an are coefficients of these two characteristic polynomial that was talking about. This is for the original one and this is for the desired closed loop locations that you want. Okay, then one more matrix you need to determine, that is your PC. Okay, so what is the formula for PC? PC is called as transformation matrix, that is given by what formula? P1, P1A, P1A minus 1. Okay, A is already known to you, that is your system matrix, but you don't know how to derive the formula for P1. How will you derive P1? That is given here, no? P1, what is the formula for P1? 0, 0, 0, final element alone will be 1 and you have to multiply the determinant with what? QC inverse. So you know what is QC. What is QC? QC is what matrix? Controllability or observability?
Controllability, ma'am.
Controllability. So remember the formula. These formula only you are going to use up in the problem solution. Okay. And one more thing, this is called a transformation matrix because it will be converting states model into phase variable form. Okay. This is called a transformation matrix. Using this matrix only you will be able to convert state space model into phase variable form. Sometimes those sort of problems will also be given. Okay. So remember that. Now we will solve the problem. Now this is your question. So what is being asked in the question? You have to consider one system that is given by what representation? Y of s divided by u of s is what representation of a system? Y of s is your Laplace transform, the output variable. U of s is your input Laplace transform. So it is equivalent to what? What representation?
Transfer function.
Transfer function. Okay, so this is your transfer function. First thing is you need to, you have been asked in the problem that you are to design the system in such a way. You are to design a feedback controller in such a way that you have to fix the pole at what location. You have to fix the pole, you have to place the poles at what location now. What are the poles that are given? What are the pole locations that are specified in the problem? You have to reframe the given system so that now the poles are located at what location?
-2 and minus
-2, -1, plus or minus J1. Okay, so pole placement they have asked. So you have to do the state space feedback. So if you want to do the state space feedback, you have to determine one matrix. What is the matrix that you will determine?
K matrix.
K matrix, and it is given by one formula, alpha 1 minus A1, alpha 2 minus A1 into PC. Okay, but how will you determine PC and all? PC is given by P1, P1A, so on. So you don't know A and all. So first thing that you will do is you are to convert this transfer function representation to a given state space representation. Okay, that is what you are going to do now. Okay, so you are going to convert transfer function to state space. Okay. This you have tried in your laboratory also by using a program. Now you are going to do it in terms of a problem. This you are going to do using physical variable or phase variable. Which one you are going to do? You are going to convert given transfer function to state space model, that is ABCD constants you are going to find out. In doing so, you are going to use physical variable or phase variable. That is my question. Are there any physical variables possible in the system? Physical variables means you know what is the meaning of physical variable that you discussed while solving problem in the first class, very first class. Using an electrical system, mechanical system, you did that. So if it is a mechanical system or electrical system, you know what are the physical variables. What are the various physical variables?
Distance, time.
Yes, displacement, time, velocity, then voltage, current if it is an electrical system. But here, is there any possibility of choosing those physical variables as state variable? Is it possible?
No.
No, ma'am. No, ma'am.
No. So here you are going to use what variable? Phase variable you are going to use. Okay, so now you understood the difference between phase and physical variable, huh? Yes or no?
Yes,
Okay.
ma'am.
Okay, now you cross multiply. Okay, bring this to this side and this to this side, like this. Okay, then you multiply all the terms in. So you will be getting s cubed y plus 3s squared y plus 2y, that is equivalent to 10u. And you know how to write s cubed, that is 3 times differentiation. So 3 times differentiation means how many dots you will have?
3 dots.
3 dots. Here you are having 2 time differentiation. So 3 into y double dot. Here you are having 1 s you will have. So 1 time differentiation, so you will be having 2 y dot, that is equivalent to 10. So you have written this equation. Now time to choose the state variable. So how will you choose the state variable? In terms of phase variable only you are going to choose. So I am assuming y is equal to x1. This is my first state variable. Then I am choosing y dot is equal to x1 dot is equal to x2. Okay. So this is my first state equation. Next thing is y double dot, that is equivalent to x1 double dot, that is equivalent to x2 dot. I am choosing it as x3. So this is my second state equation. One more equation I have to determine, that is for x3 dot. Okay, that I will do it by reframing this given equation. So in this way I will be able to frame my x1, x2, x3 dot state equation. Okay, you know how to write Ax plus Bu. Same way. Okay. So that is what they have done here. So x1 is equal to y, first state variable, x2 is equal to y dot, that is second state variable, that is equivalent to x1 dot, as I have done earlier. Okay. Now the remaining things I want to know x3 dot, that I will write it down from the given equation, that y triple dot plus 3y dot, like that. That equation goes no, so that equation in terms of x they have written, and from that equation they have obtained x3 dot. Now I have got the 3 state equations, with the help of which I can frame the matrix and I can find out what is my A. So tell me what is my A. With this I can write the state equation, which is of the form x dot is equal to Ax plus Bu. So tell me what is the equation. x1 dot, x2 dot, x3 dot, that is equivalent to my A matrix, that is 3 cross 3 it will be, I think, x2, x3 plus B into U matrix. Okay, so what is my coefficient of x1 here? Coefficient of x1, is there any coefficient of x1?
No, ma'am.
No, so 0 I will write. The coefficient of x2 is there, so 1, 0, okay. Then x2 dot, there is no coefficient of x1, no coefficient of x2, but x3 there is 1. So minus here 0, minus 2, minus 3. So this is my A matrix. I got A matrix, alright. Now B matrix is the coefficient of U. There is no coefficient of U here, there is no coefficient of U here, but here there is a coefficient, that is 10. So only for x3 alone I will be having that 0, 0, here 10 I will have. This is my state equation. We can see here, as I have written, this is my A matrix and this is my what matrix? B matrix. Okay, A and B alone is enough. There is no need for me to find out C and D, because I am not going to test observability. Only controllability is the first check that I will make. So I am not going to derive C and D or output equation. So I know what is A, B. With the A, B, I can determine the QC matrix, which is given by B, A, B, A squared B. Okay, test for controllability using Kalman's test I am going to do. So this is a standard matrix. The first test that I will do is this controllability test only before going for state space feedback. So this is my A matrix and this is my AB matrix. You know how to multiply matrices. So I am not going to discuss that in detail. This is A squared B. So I have got these three. I will compile them into QC, controllability matrix. And what is the condition if the system is to be controllable? I told you, no, Kalman's test of controllability. That QC matrix should be equal to non-zero or a zero element.
Non-zero.
Non-zero. So if you are deriving the determinant is minus 1000. Okay, which is not equal to 0. So you can clearly say that the system is completely state controllable. So this is your first check that you will be making for the problem. You will be checking out controllability. Next thing is you will be finding out what is the inverse of that controllability matrix by using what formula as usual. What is the formula?
Adjoint A upon determinant.
Cofactor of QC transpose divided by determinant of QC you are going to find out for determining the QC inverse. Okay. This is a 3 cross 3 matrix, so it will be a difficult job. So if you want to, means you have to find out the adjoint of every element. I think in the book this answer is wrong. I think it will be 200 or something. So make a note. There is some mistake in the problem in the book. Next thing, for each and every element, for 0 you will be finding out cofactors, so adjoint by this. It will be 700, I think, minus 900 or something. So 200 you will get here. Like that you have to frame all the cofactor adjacent, what is the name I don't know. So for each and every element you have to determine the, what is the name that you usually give? Adjoint, what? Cofactor.
Adjoint, ma'am.
Adjoint. So each and every element you will find out the adjoint and you will give alternative signs as usual. So for 0 you will be taking this adjoint like that, okay. So you will frame this and then you will take the transpose, and the determinant as you have already seen is 1000. So you will be finding out QC inverse by this way. The next thing is, as I told you, they have given 3 pole locations. What are the 3 poles that they asked for you in the problem? They have told you that you have to locate the pole at -2, -1 plus j1 and -1 minus j1. So this is mu1, mu2, mu3 you have to consider, and you have to reframe the new characteristic polynomial in this fashion. So you substitute u1 here, mu2 here and mu3 here, and you form the characteristic polynomial. So this is your new one, for which you have to locate the poles in the new positions, -2, -1 plus j1 and -1 minus j1. Now you have to compare this equation to the original lambda I minus a. Okay. So this is your new one. Old one is the usual one, del I minus a. You know what is the A matrix? Using this formula you can easily calculate the original matrix. And you are going to compare these two equations, okay. The coefficients of this one, the coefficients you have to find out, and you will take the difference, because k is equal to alpha 1 minus a1, alpha 2 minus a2, alpha 2 minus a3. Okay, so we will take the difference between these two. Take the subtracted value and you substitute it here. Take the subtracted element and substitute it here. That is K matrix. For that purpose only you are doing all these things. So as you can see here, the state space feedback gain matrix, it is given by alpha 3 minus a3, alpha 2 minus a2, alpha 1 minus a1 into PC matrix. So you know the characteristic polynomial, one is obtained by lambda I minus a and the other one is obtained by mu1, mu2. So both these things, coefficients will give you alpha 3 a3, alpha 2 a2, alpha 1 a1. That you are going to substitute in the formula for K and you are finding that out. But still you need to multiply that with PC matrix. So there is a formula for PC. What is the formula for PC? What is the formula for PC? You have to find the matrix of P1, P1A and P1A square. A is already known to you, easy. But what is the formula for P1? P1, what is the formula that is given? How many people are there in the class or not? Are you able to understand the concept or not? Simple formula and substitution only. So what is the formula for P1? It's a 3 class, 3. So the final element will be 1. So 0, 0, 1 into QC inverse. QC inverse you have already found out. That you substitute and find out P1. Then you have to find out P1A, P1A square. Then if you take the determinant P1, P1A, P1A square, that will be equivalent to your transformation matrix PC. Okay, that you are going to find out. Okay, so this is your PC value that you are substituting here with the product of K matrix. So this is the final step, with the help of which this problem will be over. So this is the design of the state space matrix, feedback matrix, with the help of which you will be able to locate the poles at what location? What are the pole locations that are specified in the problem?
-2 and -1 plus minus J1.
Yes, -2, -1 plus or minus J1. You want the pole to be changed to this. So for that the state space feedback gain matrix should be designed like this. And how will you design K? What is the formula for it? What is the formula? Alpha 3 minus A3, alpha 2 minus A3, alpha 1 minus A1, PC. Okay, PC, how will you determine? That is a transformation matrix that you are going to determine by using P1, P1A, P1A squared. A is easily that system matrix, but if you don't want to find out P1, what is the formula for P1? P1 is 0, 0, the last element will be 1 into QC inverse you will take. QC is nothing but controllability matrix, for which you know B, A squared B is the formula. For that inverse you have to take and you have to multiply that with 0, 0, 1 to find out P1. Then you will easily get PC. What are alpha 3, alpha A1, all those things, sir? Those are nothing but, there are two polynomials that you are going to derive. One is for the original lambda I minus A, the coefficients of which will be A1, A2, A3. Okay. And you are having the pole location desired at these 3 points. Using that you are framing one more characteristic polynomial using this formula, and for which the coefficients will be alpha 1, alpha 2, alpha 3. Understood the problem or not?
Yes, ma'am.
Okay. Okay. So you understood these concepts. Okay. First concept is how to convert a given transfer function to a state space model. How will you convert? Using what formula? Using space variable you will do the conversion. Okay. That you have to understand. Next thing is how to do the reverse conversion. If you are being given with the SS model, if you are being given with A, B, C, D constants, I want to obtain the transfer function. So how to do that? That is also another problem that we will learn out today. There is a simple formula only that those sort of questions might be asked in MCQs. So I will teach you that problem. Wait, let me load that. Okay. You can see for yourself, there is some formula that is given. Okay, what is the formula that is specified there? Are you able to see or not?
Yes, ma'am.
That equation that I am circling? Or there is a delay in the screen? Somebody should tell me what happens in the screen, otherwise I will not know. Are you able to see the screen? properly, that equation that I circled?
Yes, ma'am.
So what is this equation corresponding to? What type of conversion? In the earlier problem, you have been given with one transfer function. Okay, y of s divided by u of s was given, from which you are determining a, b, c, d. Okay, so you learned how to convert transfer function to set space model by using the phase variable. Now you are going to do it in the reverse way. Reverse way means you are being given here, the problem says, this is your state equation, this is your output equation. So you are being given with the A matrix, B matrix and C matrix, and you have been asked to convert that into a transfer function. So what is the formula for doing that? What is the formula?
And C matrix into Si minus A inverse into B matrix.
This one. This is your transfer function. You are knowing what is A, B, C. Yes. Remember this formula. Formula alone may be asked in MCQ, or they will ask you what is the transfer function. Either way they will be asking you. So you know what is C, you know what is A, you know what is B from these two equations. You substitute that and you can find out what is the transfer function. Now try to do it and tell me the answer. With that we'll close the class. One more topic is left out, that I will take it tomorrow or day after tomorrow. Go and solve this problem and tell me the answer. Remember, this is very important concept, how to convert state space model to transfer function and transfer function to state space model. Either thing will come in MCQ or a big mark question. So if you are being asked with state space model to TF conversion, the formula is this one. You know what are A, B, C, D constants. Just to substitute in the formula, you can find out the transfer function. Okay, I will tell you again the given equation. For the state space model, you have to find out the transfer function. Find it and tell me the answer. Work it out. Are you people doing or not? Simple problem only. Consider this is an MCQ and tell me what is the transfer function. Formula also is shown. C into Si minus A inverse B. That is a formula for converting state space model to transfer function. Both are included in your syllabus. The left out topic is only pole zero cancellation. That I will take it day after tomorrow and I will finish the syllabus. Come on, are you people trying it out or what? One of you should tell me the answer, otherwise hand pick. Pratish, Pushottam, Pushpesh, Raj and all trying out the problem or not?
Yes,
Satvik,
ma'am. Trying.
Yes, ma'am.
try and tell me the answer.
Yes, ma'am.
These sort of questions may come in MCQ. If you are telling the answer, we'll wind up. See, in case if you have not submitted the last 4 experiments, do submit. This is the last call I am giving you. After this, I will not remind you. I will simply put 0 for those who did not submit. And what is answer? Rough answer. What is Si minus A to the inverse? Nothing. You have to submit, substitute A here. And you have to take Si minus A to the inverse. The determinant is this one for that. And this is a cofactor. Transpose. So this will be Si minus A. Then C you have to substitute here and B you have to substitute here and you have to find out the transfer function. Have you got 1 by S plus 4S as the answer? Last unit is all about matrix manipulation only. So be thorough with matrix multiplication and all. Have you got 1 by S plus 4 as the answer?
Yes, ma'am.
So you understood how to convert state space model to transfer function. What is the formula again for one final time? Do remember this formula again and again. I am telling you. C into Si minus A inverse B. Very important question. Maybe asked in your future competitive exam also, like civil service or IAS exam. Very important formula. C into Si minus A to the inverse and B. All the product you have to take it and this will give you transfer function. The reverse is also possible. Reverse it is already easy. Just you have to pick the state variable and you form ABCD, that state space model. Alright. The last topic that is left out is pole zero cancellation. That I will discuss tomorrow because it is a little bit complicated. With that, the syllabus for control system will be over. And I think I have got material for that left out experiments that I will forward it. Consider all those 3 experiments as your study experiments and make a note of it. Alright. Some only 12 experiments are given for your testing and all. Apart from that, some other experiments 3 number are there. I will forward the material. If you are having free time, just to go through it. I don't know what they are going to do with the rest of the experiment, but make it as a study part. Alright. They will also give you some general knowledge about control system. Okay?
Okay, ma'am.
Okay, so with this we'll wind up class. Only one more topic is left out, pole zero cancellation. Alright, and how to convert state space, how to pick state space variables and physical variables we have learned, phase variables we have learned. One more thing is how to use canonical variable. These 2 things I will try to teach you tomorrow or after tomorrow's class. With that, syllabus will be over. Okay, with this we all can discuss. All of you to leave.
Ma'am, do we have lab session in the afternoon?
Lab session will not be there. If you want, means I will finish portion today. You want? See, and one more thing for university lab also, if you tomorrow, what?
Ma'am, tomorrow only you finish, ma'am. But
Day after tomorrow only I am having class, I think so.
Yes, ma'am.
Day after tomorrow only I am having class. Day after tomorrow, afternoon class 1 to 2 I am having. All the left out topics I will finish in that class. Okay?
then today lab session will be is cancelled.
Today there will be no lab class.
Okay.
But attendance will be given. And one more thing I am telling you, next time I will not ask a choice. I will give whatever questions I wish to you. Okay, and you are not supposed to open the Microsoft Word document side by side in your system and you just copy everything. Alright, try to learn out. This time I was lenient for all the assignment copies and all the lab copies, and I have given marks anyways. The same thing I will not do for university. If I find anybody copying from the MS Word document, then if 0 I will get. Okay, all can disperse.
Thank you.
Ma'am,
Thank you, ma'am.
will not be having lab today.
No lab, but attendance I will give. Do you want lab session? If you want means I will keep. No problem from my
No,
side.
ma'am. No.